Hello viewers, welcome back to another section of my tutorial. In this video we're going to solve a differential equation problem which falls under non-exact type of differential equation. So it says solve 2y dx plus x dy is equal to 0. Kindly subscribe to this channel and don't forget to like as well. So this is non-exact differential equation. So how do we know that? You have to test whether it is true, or you have to test using the exact method of testing to see if it's really not an exact. So every exact equation is in the form m dx plus n dy is equal to 0, where m and n are function, and we can draw a correspondence here that m is 2y as well as n is x here. So to show that it is indeed an exact, then it should satisfy the fact that since here is the x, we are going to differentiate with respect to y, and since here is the y, we are going to differentiate with respect to x. So differentiating here 2y with respect to y is giving us 2. Differentiating here with respect to x will give us, so x, when we differentiate it with respect to x, we get 1. 2 is not equal to 1, therefore this equation is not exact, hence it will fall under non-exact category. For that reason, you have to use the method of non-exact to convert it to exact, and to do that we are going to use an integrating factor which is derived from a formula written by my. Here we differentiate with respect to y, so we call it my. Then here we differentiate with respect to x, so nx. So we say my minus nx all over n should be equal to a function in terms of x only, and if it holds, it means we can use that to find our integrating factor. So let's see, our my was 2, our nx was 1, all over the n, which is x, will give us 1 over x. Since this is a function in terms of x only, then we can go ahead to find our integrating factor with that. So our integrating factor mu of x is simply equal to e to the power integral of 1 on x dx. Then this is going to give us e to the power ln of x, simply x. So our integrating factor is now x, and what you are going to do is to multiply through by x. So 2y multiplied by x dx plus x multiplied by x dy is equal to 0. We move ahead to write 2yx dx plus x squared dy equals 0. Now this has now been simplified to a form which you can apply the exact method. So what do we do now? We have to integrate each term, that is for the dx side and the dy side, and we merge. So you find integral of 2yx dx, then integral of x squared dy, and after we merge. So when I integrate here, I'm going to get, with respect to x, that's going to give me x squared over x squared y over 2, then there is 2 here, like that. Then this place is going to give me x squared y, because I'm having x squared here and I'm integrating with respect to y. I'm going to get x squared y. So let's see, here is going to give me x squared y like this, and here is also going to give me x squared y. So once I get this, when merging, they are the same, so I just take 1. So therefore I'll get x squared y is equal to c as the solution, general solution for my differential equation. But since this is in the implicit form, let me leave it in the explicit form by making y the subject. So y is simply equal to c over x squared, as simple like that. Thanks for watching this video. Don't forget to subscribe so that whenever I post interesting questions like this, you'll be able to get it. Thank you.